Bismillahirrahmanirrahim. In this video, I am going to explain what is the issue of endogeneity, that is, what is endogeneity bias and how is it detected using STATA. So let me explain some of the background information. One of the assumptions of ordinary least square technique is that expected value of error term given x is equal to 0. And in this case, it implies that the covariance of epsilon, that is error term, and the x variable is 0. So if this covariance of error term and the x variable is 0, then x is an exogenous variable, that is, it is determined outside the system or outside the model. In this case, we can apply the standard OLS method for estimation, and the OLS estimator in this case is unbiased, consistent, and effective. The problem starts if the covariance of error term and x is not equal to 0 IA, that is, when x is endogenous, which means that x is determined within the system. In this case, the OLS estimator is biased and inconsistent, and none of the usual hypothesis testing using t-test and f-test are valid. Thus, when x is random, the relationship between the random error and x is crucial factor when deciding whether OLS is appropriate or not. So our conclusion is, if the covariance between the error term and the x variable is not equal to 0, the OLS estimator is not only inconsistent but also biased. And the value of this bias, that is endogeneity bias, is given by the ratio of covariance between error term and x divided by the variance of x. Now, a real question is, what is endogeneity? For that, let us consider a regression equation yi, which has two explanatory variables x1 and x2, and finally we have the error term epsilon I. In this regression, yi is regressed on two x variables, that is x1i and x2i, and epsilon I is the random error. If x1i and x2i are uncorrelated with the error term epsilon I, then x1i and x2i are exogenous variables. On the other hand, if either x1 or x2 is correlated with the error term, then that variable is an endogenous variable. But what is endogeneity? We should be very careful about endogeneity, because when the endogeneity problem is present and it is ignored, then it can lead to biased estimates. If the estimates are biased, then the true effect of a variable on the outcome of interest would be either overestimated or underestimated. Now, there are three causes of endogeneity, and some of the most common causes of endogeneity include omitted variables case, simultaneity case, and the sample selection in the estimated equation. Omitted variable bias occurs when a variable that influences both the independent variable as well as the dependent variable is excluded from the model. I'll explain that with an example. For example, consider a regression of wages on the highest level of education x1 and on the inherent ability or innate ability measured by x2 of an individual. And in that case, the true model is given by yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus epsilon I. Now, x2i, or the innate ability or the inherent ability of an individual, is usually unobserved or difficult to measure. In that case, one might be tempted to run the following equation. And let us suppose the estimated model is yi is equal to beta naught hat plus beta 1 hat x1i plus vi. Here y is wages, x1 is the highest education qualification, and vi is error term. The terms beta naught hat and beta 1 hat are estimates of true population parameter beta 1 and beta 2 respectively. The inherent ability of an individual in this case influences both their wages, that is the dependent variable, and their highest educational qualification, which is the independent variable. So x2, which is ignored in this model, influences both the dependent variable yi and the independent variable xi. And it can be shown that for this shorter regression, x1 and the error term v are correlated, and that result in endogeneity bias. The endogeneity bias resulting from omitted variables is called omitted variable bias. The second cause of endogeneity is simultaneity bias, which occurs when causality runs from both x to y and from y to x, which is a reverse causality. For example, think of the market price of a can of Sting drink, and let us suppose that the market price of Sting declines. Usually more cans are sold. This is the famous law of demand. At the same time, when more cans are traded in the market, for example due to the onset of festive season, the quantity traded will also influence the price of a can of Sting drink. The price and quantity traded of Sting drinks are simultaneously determined in the market. When reverse causality is present but ignored, then the estimated equation will suffer from simultaneity bias, and simultaneity bias also leads to endogeneity bias as well. In this lecture, we will deal with the omitted variable bias, endogeneity bias due to omitted variable. So the question is, how is endogeneity tested? In practice, the test of endogeneity will be applied after estimating the two stages least squares. Assume our results are as follows, and this is the test of endogeneity. Here the null hypothesis is that variables are exogenous in the model. But if the Durbin chi-square and the Wu-Hausman f p-value are less than 0.05, then we reject this null hypothesis. Since these values are less than 0.05, so we conclude that variables included in the model are endogenous rather than exogenous. So the results of the test show that we can reject H naught since the p-value is less than 0.05. Hence, we can conclude that x1 is endogenous and the estimates of two stages least squares are appropriate. After testing for heterogeneity, we use the first stage regression statistics with this STATA command, stat first stage, and it reports various statistics that measure the relevance of the excluded exogenous variables. Let us suppose this is the first stage regression summary tables. Here two things are important. One is this partial R squared, which shows the correlation between the endogenous variable and the instruments. This is not very high. And secondly, we must also consider this F test. And this is the computed value of F test, and we must compare this value here with these values. If this value is higher than all these values, then we reject this null hypothesis that instruments are weak. Since this is greater than these values, so we reject the null hypothesis that the instruments are weak, and we can safely conclude that the instruments that we used are not weak. So, as I mentioned, here we can reject the null hypothesis that the instruments are weak because the test statistic is 59.07, which exceeds its critical value of 19.93 with the nominal 5% wall test. On the basis of this test, we do not have a weak instrument problem because our model has only one endogenous regressor. The minimum eigenvalue statistic is equal to F statistic reported in the first table. The third test is that of over-identification restriction, and for that we use the command stat override, and it performs tests of over-identifying restrictions. If this test is statistically significant, it always indicates that the instruments may not be valid. Let us suppose this is our output of the test. This test stat override, and both Sargan score chi-square test value and Wu-Hausman chi-square value both have p-values which are greater than 0.05. So we fail to reject the null hypothesis that our instruments are valid. So it means our instruments are valid. Now, after this theoretical discussion, I'll practically show how to do this. For this purpose, I'll open my STATA file. Here is my STATA file. Let me clear the screen, and my file is educ wedges DTA. That is the STATA file which is available online, and you can download it. Now let me first of all run the OLS, the ordinary least square regression, that is the simple multiple linear regression model, and here I will say regress wedges on union and education. Now this is the output of the model, and this is the command regress wedges on union and education, and this shows that if someone is a member of union, he has almost $2,000 more annual income than a non-member of union. Similarly, one extra year of education leads to more than $1,000 to the annual income. Let me store this estimate, and later on I will compare with other models. So I'll call it sto OLS. So it has been stored here. After this, now in this model, as I mentioned, education is endogenous because a person has also inherent ability, and that inherent ability influences both education of the individual and his income. So we assume that this is an endogenous variable. Now after this, I will use the instrumental variable regression using two stages least square, and in that I will use this command IVreg, and it is a, let me write this command. I have already this here. So I write IVregress two stages least squares wages is my dependent variable, union is my independent variable, and here I'm using instruments, that is father education and mother education, as instruments for education. So let me see what does it mean. So this is the output of the instrumental variable regression involving two stages least square, and if we compare the coefficient for education here is less than this one. For union is almost the same. So I will also store the estimates of the instrumental variable regression, and after this I will use a test of endogeneity, and here is the command for endogeneity. So this is ESTAT endoge. So this is test for endogeneity, and giving this command is tests of endogeneity, and here the null hypothesis is that variables are exogenous. But both Durbin chi-square and Wu-Hausman F test shows that the p-value are less than 0.05. So we reject the null hypothesis that the variables are exogenous, and we conclude that the variables that we use are endogenous. So we must not use the ordinary least square. Instead, we should use the two stages least square. Now after this, I will use another test, that is the first regression, the first stage regression test, and this is the command for state first stage. Now here this one, this value, that is partial r squared, and this f state, these are very important. This partial r squared shows the correlation between the endogenous variable education and the instruments, that is father education and mother education, which means parent education, and it has been adjusted for the union membership. Secondly, this is important, and we must compare this value of test with these values of test. Since this value is much higher than this value, so this is significant. So we reject this null hypothesis that our instruments are weak. Since we reject this null hypothesis, so we conclude that the parent education, which was used as instrument for education of the individual, is not weak. That is, the mother education and the father education as instruments are not weak. After this, we will use another test for overidentification, and here is the test, and this test basically tells us whether the instruments are valid or not. The null hypothesis is that the instruments used are valid. So in this test we have two. One is Sargan score test, chi-square test, and one is Wu-Hausman chi-square test. Since the p-values associated with the Sargan chi-square test and the Wu-Hausman chi-square test are greater than 0.05, so we fail to reject the null hypothesis that the instruments used are valid. So in this case, there is endogeneity, and the instruments are not weak, and the instruments are valid. So in such cases, we must use the two stages least square, or the instrumental variable regression involving two stages least square rather than ordinary least square, because if you use ordinary least square, then the estimates are not only inconsistent but also biased. But in case of two stages least square, the estimates are consistent. After this, I regress another model, and here I regress education on union as well as mother education and father education. So this is my first stage equation, and then I predict education hat. Since I have already predicted here, so if I give this command, it will not be predicted because this already exists. So I have it already here, so we shouldn't worry about this. Next, I will use this regression in which I will use wages on union and the predicted value of education. Here, instead of usual education, we use the predicted value or the estimated value of education, and in this case we have, this is the coefficient for education and this is the coefficient for union, and these are exactly the same, but I will do one more thing. I will also store this. So here it has been stored, and after this I will give this command est out. So it will give me the output of the OLS and the output of the instrumental variable regression and the output of two stages least square. So in this model we can see this is our OLS estimates, this is the coefficient for union, this is the coefficient for education, but since this education is endogenous, and on the basis of the three tests we found that education is our endogenous variable, and the instruments are not weak and the instruments are valid, so we must not use this because these estimates are not only inconsistent but also biased. This is the output of the instrumental variable regression, and this coefficient for union is almost the same, and for education this is a little bit less than this, and this is the constant. But if we compare for both the instrumental variable regression and the two stages least square, the coefficient for the union is the same, and the coefficient for education and here education hat, that is the predicted education, is exactly the same. So either we may use instrumental variable regression or two stages least squares. So most of the researchers and econometricians claim that this is better than this, because in this case the standard errors are not as large as in the case of two stages least square. So we must focus on instrumental variable case. So ladies and gentlemen, you saw a number of things. I was estimating the Mincer earning function in which I regressed wages on education and union, and we found out that education is an endogenous variable, so we use instruments, that is parent education, and then we use three tests, that is the Wu-Hausman test, which showed that the variables are exogenous, because these p values, the Durbin chi-square and the Wu-Hausman associated p values are greater than 0.05. Then we used another test, the first stage regression, and that also showed that our instruments, that is the parent education, mother education and father education, they are not the weak instruments. And finally we used the Overidentification test, and it showed that these instruments are valid. So we must report the instrumental variable regression two stages least square instead of the OLS. So this is very interesting, and I hope this was helpful for you. If you have any question, you may ask me in the comments below. So I thank you very much for watching this video. If you haven't yet subscribed to the channel, kindly subscribe the channel, and do not forget to click on the bell icon so that you can get notification about my other videos that I'll upload for you. Thanks for watching this video and the channel. Kindly share this channel and various videos of this channel with your colleagues.